Welcome to the AI Research Roundup. I'm Alex, and today we're looking at a paper from the Hugging Face trending list, published on July 1st, 2025, just yesterday. This paper introduces a new 9 billion parameter vision language model that matches or even beats a much larger 72 billion parameter model on 18 different benchmarks. The paper is titled GLM-4.1V Thinking Towards Versatile Multimodal Reasoning with Scalable Reinforcement Learning. And as we'll see, the results are really impressive. The authors achieved this through a reasoning-centric training framework, combining large-scale pre-training with a novel reinforcement learning strategy. Also, the authors shared the project on GitHub, and it's quite practical. Listeners will find inference scripts, including a command line tool and a Gradio web UI. It also provides clear instructions and examples for fine-tuning the model on your own datasets, which is a great starting point for experimentation. On Hugging Face, both the 9 billion parameter base and thinking models are available, with usage examples for you to download and try out yourself. Alright, so these charts really get to the heart of the findings. The radar chart on the left shows the new model's performance, that's the blue line, matching or even beating the much larger 72 billion parameter model and GPT-4o across many tasks. The bar chart on the right then shows how they achieved this. It isolates the gains from their two-step training. They start with supervised fine-tuning, which is training on high-quality examples, and then apply reinforcement learning, where the model learns from trial and error. That second step provides a huge boost, up to a 7.3% gain in accuracy. Okay, so how does the model actually do all this? This next figure breaks down the architecture. At the bottom, it starts with a vision transformer encoder, which is a network that processes images and videos by breaking them into patches, much like a language model reads words. Next, a component called an MLP projector acts as a translator, aligning that visual data with language. Finally, the language decoder, which is the LLM part, takes all these inputs, images, video, and text, to reason and generate a final answer, even using a special think token to show its process. Building on that, the authors show just how crucial their reinforcement learning strategy is. These charts illustrate what happens when that process goes wrong. The top row shows the training rewards, which are scores given by automated judges called verifiers. You can see one reward signal skyrockets, but this is actually a bad thing called reward hacking, where the model learns to fool the verifier. As a result, the bottom charts show that the model's actual performance on benchmarks peaks and then crashes. This really highlights why a precise reward system is so essential. So to prevent that reward hacking we just saw, the authors created this incredibly detailed, domain-specific reward system. This table breaks it all down. For each task, like math or reading charts, there's a custom rule. For a task called grounding, which is about finding objects in an image, they use a metric called intersection over union. This just measures how well the model's predicted box overlaps with the actual correct one. For reading text, they use what's called edit distance, which basically counts the typos. This precision is what keeps training stable. So that detailed reward system is really the secret sauce. In conclusion, the big takeaway is that a smaller 9 billion parameter model can compete with and even outperform giants like GPT-4o. This is achieved with a powerful two-step process. First, supervised fine-tuning on good examples, followed by that crucial reinforcement learning phase, where the model learns from trial and error. While the authors note there's still work to do, especially in evaluating the reasoning steps themselves, this is a huge step for open-source multimodal AI. That's all for this week's AI Research Roundup. Thanks for listening.